Okay, so we're starting out our first journal here. And just to remind everyone, when you're doing your journals, you can really do it any way you want. The only thing I would say is that make sure you title at the very top of when you start a journal, the journal number. So this one's journal 1, and make sure that I can see that because when I'm grading your journal, I need to know what entry that I'm reading. So when you do your journals, you should have like definitions written down as I'm going through these notes, and a few examples. If I don't see a few examples and the definitions, I'm not going to give you full credit. Um, but other than that, you can add and do however structure you want for your journals. That's on you, whatever makes you feel comfortable. So let's start today. This is the bell work. I will present you a bell work every day, well, at least almost every day in class when we're doing a journal. And so let's start with this problem here. So A and B is asked to simplify the expression, and you can see that I'm giving you guys a math expression, and there is a number in front of a parentheses. Now, you might have learned somewhere in Algebra 1 that you need to distribute the number in front of the parentheses into what is inside. So that means it gets distributed to the x and the -2. So -3 times x is going to be -3x. So what I did was multiply. Then I'm multiplying the -3 with the -2, but that's going to give me +2, right? Because I'm sorry, not +2, +6, because we know that two negatives multiplied together will make a positive, and 3 times 2 gives me 6. And so now I've distributed my number, and I get to bring down that 5 that was there before. But hold up, we're not done, right? We can combine the 6 and the 5 because they're both numbers. They are like terms, is what we call them. So 6 plus 5 gives me 11, bring down the -3x. And then I try to combine again, but oops, I can't combine because that's a variable and that's a constant. So I can't combine those. Those are not like terms. So I am done with that problem. Okay, now with this one here, same thing. I notice there is a number in front of the parentheses, so I'm going to go ahead and distribute those numbers. I'm going to distribute the 2 perhaps first, and then I'm going to distribute, well, let me distribute the 2 first. So 2x minus 2. And here I have a 3, but it's a -3 here because there's a minus sign in front of that 3. So what I'm really doing is distributing a -3. So be wary of that. So I have -3x plus, because that's a negative times a negative. So that's going to be plus 18 because 3 times 6 gives me 18. And now it's just a matter of combining like terms. So I notice that I have, an x here and then another x. If I combined 2 with -3, I get -1x. Or you could say that as -x. And then if you combine the numbers, so that's these two, they're both numbers. -2 plus 18 gives me +16. So you can either write your answer like this, or you could have written as -x plus 16 without the 1 in front of the x. Because let's remember, whenever x doesn't have a number in front, you can always assume it's 1, because 1 times anything is just itself. So whether you write the 1, whether you don't write the 1, doesn't matter. Know that the 1 is always there. Okay, let's talk about order of operation. Now, you should have talked about this even in 8th grade, but you should have definitely talked about this in algebra. So let's go over what they stand for. So P stands for parentheses. E stands for exponent. M stands for multiplication. I'm just going to write multiply for short. D stands for divide. A stands for add or addition. And S stands for subtraction. Now, here's the thing. When it comes to multiplication and division, they're actually thought of equivalently. Like the order that you do multiplication and division are on the same level. The only thing is, because we live in the Western world, or the Western part of the world, we actually have to do it from left to right. Okay, so we always do multiplication or dividing from left to right is the order. And same thing with addition, it's from left to right. So if you need to know which one you have to do first, multiply or divide, it doesn't matter as long as you're doing from left to right. Same thing with addition, as long as you're doing from left to right. The reason why is because we read from left to right. Like when you open up a book, you typically read from left to right in America. Well, in math, in America, we also do math from left to right. So that's how I can remember that. And so these are the set of rules that we use to simplify or to work out expressions, mathematical expressions, and equations. So that is our bell work for today. So let's hit into today's lesson. All right, so here I have some inequality symbols. You should have seen these symbols before. Definitely these four, maybe not this one here. So let's go over these again. And just like I said before, we read left to right in mathematics. Well, these inequality symbols actually refer back to that too. So let's go over these symbols. The first one here is less than. So this, because the mouth or the crocodile, you know, what your kindergarten teacher said long before, the crocodile mouth is facing to the right, this is going to be less than. How I know that is because let's say I were to write this out as an example. Like 7, okay? So here's an example where I use this symbol here. Notice when I read left to right, this has to be 3 is less than 7 because the mouth is facing the 7, so 7 has to be greater. So when you're reading from left to right, you can already see that this has to be, this item here, it has to be less than. And then the second one here is greater than. And then anytime you have a line underneath those inequality signs, then that means that it also equals that value. So this one would be less than or equal, and this would be greater than or equal. So hopefully that, jogs memory lane for you guys. And last but not least, this guy looks like an equal sign with a slash through it. Well, that's because this means not equal to. So if anytime you see this symbol, it means that that thing is not equal to the other thing. Okay, and that's it for inequality signs. We are going to be using these signs heavily in the next few sections, so keep these in mind. All right, last slide for today. So we're going to go over some math vocabulary here. Let's talk about expressions and equations. Oftentimes, a lot of math teachers will use this intertwine and might even use it incorrectly. And as students, I think we often get confused that these are the same, but they're not. So expressions in math, I like to think of it as a math phrase that combines numbers and variables and operators. Operators are like your plus sign, minus sign, division, multiplication, even equal signs are your operators, okay? So like an example of an expression here would be like this side here. Notice that you have some variable added an operator with a number. So that all combined, let me write that a little higher. So that all combined is what we call a expression. Now, expressions don't have to be a combination of these items. It just has to be one of these items, these 3 items that I said before, a number, a variable, or an operator. So over on the other side of the equal sign, this 20 is also considered an expression. So the 20 can also be thought of as an expression because it's standing alone as representing some sort of value. So with that being said, whenever you have 2 expressions equaling each other, that's an equation. Notice how the equal, the EQ and equal, and the EQ and equation, So Equations are two expressions equal to each other. So in this hierarchy, when you combine these two, you get an equation. And also, let me just also explain down here, this one item in an expression is what we call a term. So I like to think of terms as an individual item in an expression or an equation. So this would be a term, the 5 would be its own term, and the 20 would be its own term. So that's what we call a term. And now let's go into what these numbers represent by where they're placed on this equation. So notice this 3 is in front of this x here, right? So this 3 represent what we call a coefficient. And you might have heard that before from your math teachers, but we call it a coefficient because it is next to a variable such as x or any type of letter of the alphabet or symbol. And so variables are generally a symbol that is representing a number. We usually use that as x, so we call that a variable. So it's some sort of unknown number. Now this 2 here, this tiny 2 up above where x is what we call an exponent. Sometimes people refer this as a power or degree. But I like to say exponent more often because it's more of a universal term. Like in Spanish, exponent is said to be exponente. So very similar wording. So I like to use exponent instead. And last but not least, we have this 5 here, and that is going to represent our constant. So that's what we call our constant. So when a number stands by itself, notice how this number here doesn't have a variable or an x next to it. This is what we call a constant because it's a number by itself. And also this 20 is also a constant. And so you can see how like these make up the terms and the terms make up the expression, and equations with equal signs equal an equation. So you can see that hierarchy builds upon itself. So I hope that clarifies a few vocabulary for you. And so there's no homework after this journal entry, but you might be able to start the first problem in page 1 of packet 1, so feel free to try that out. But I'm going to assign homework in the next journal. So I hope this helps you out.